Evaluate the related series of each sequence. All right, series. When we see the word series, we know we're looking for a sum. So it's going to be one of these two, here or here. So we need to figure out if it's arithmetic or geometric. So look at the numbers, look at the pattern. It looks like, what, +9? +9 tells me this is arithmetic. So for arithmetic, we're going to need this, n over 2 times a1 plus an. The sum of n numbers equals n over 2 times a1 plus an. So n is how many terms there are. 1, 2, 3, 4, 5, 6, 7. 7. A1 is the first term, 29. And an is the last term, 83. So let's check it out here. We've got 7 over 2 times 29 plus 83. 392. Now what we've just found is the sum of all those numbers. So another way of doing this problem is just to literally just add those numbers up. And that's fine, you can do that, but sometimes it's going to be really hard to do that. Sometimes you won't have enough information to do that. For example, in this one, we're not going to have enough information. We can't just add up a bunch of numbers. We're going to need that same formula. Evaluate the series. So we've got that same formula, n over 2 times a1 plus an. Go back and look at the formulas if you need to. N, in this case, was given to me as 5. A1 is 21. An is 49. So it's a very straightforward problem, 5 over 2. You can type in 2.5 if you know that's 2.5 times 21 plus 49. 175. That's the sum. We just evaluated the series. Now the next one, I know people always freak out when they see that sigma symbol, but sigma means sum. It's the same thing. So if you look at the same formula, we still need to know those same things. Now n is the number of numbers. So what this is telling me to do, it's saying plug in 1, and then plug in 2, plug in 3, plug in 4, plug in 5, plug in 6. The last number I'd plug in is 6. But n is how many times we would end up doing that. So if you count on your fingers if you want to, plug in 1, 2, 3, 4, 5, 6. That means n has to be 6. It's not always the case that we're going to use that number 6 right there. It just depends on how many numbers we'd end up plugging in. In this case, we plug in 6 numbers. A1 is that first number. When we plugged in 1, we got 0. An is that last number. When we plugged in 6, we got 35. So we're going to end up doing 6 over 2 is just 3 times 0 plus 35 is 105. That's the sum. That's the sigma. Evaluate the series. We're still doing the same thing. Evaluate the series. So pay attention to the pattern. This is what, times 6? Times 6, so I know this is geometric. Okay, this is geometric. So look at the sum for a geometric. Seems kind of complicated. A1 times the quantity 1 minus r to the n all over 1 minus r. That's the geometric series. So again, we're just going to plug in what we need. A1, that's easy. That's the first term. R is this number. It's what's happening. It's the pattern. And n is the number of numbers. So 1, 2, 3, 4. There are 4 numbers. Now, if I'm going to plug this in on a calculator, you better put parentheses there, otherwise you're not going to get it right. So we have -2 times 1 minus 6 to the 4th, and divide by 1 minus 6 in parentheses, or else call that -5 if you want. We get -518. That's the sum. 29, same thing, it just has a sigma. So we still have that same formula. It's a geometric series, you can tell because of this 2 right there. And it's a1 times 1 minus r to the n over 1 minus r. So a1 is just what you get when you plug in 1. So 2 to the 1 minus 1, plug in 1, you're going to get 2 to the 0. Anything to the 0 power is 1. So a1 is 1. You have 1 minus. And r in this case is just whatever the base is on the power. So that's 2 here. And n is how many numbers are going to end up plugging in. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 9. And r, of course, is still 2. So we look like that. When you plug in, if you're going to type this in, you better put parentheses there. We have 1 times 1 minus 9 to the, what was it? Messed that up, not 9. It was 2 to the 9th. All over parentheses 1 minus 2. Okay. Looks like we get 511. That's the sum. And number 31. Notice this is an infinite geometric series. And notice you see the infinity symbol there, but infinite is a little bit different. It's a little bit weird. It's kind of weird to think about an infinite number of numbers might have a sum. But we look at our formulas, and sure enough, there's a formula for an infinite sum here. Only for a geometric. Notice there's not one for arithmetic, but there is one for geometric. A1 over 1 minus r. So the formula is actually a little easier than the one that we just used. A1 over 1 minus r. It's important to notice that this only works if this r number is in between -1 and 1. Sometimes you think of it as less than 1. It has to be a fraction or a decimal number less than 1, or in between -1 and 1. Otherwise, it's not going to have a sum. But think about what A1 is. For A1, you would plug in that first number, so you'll have 45 times -1/3 to the 1 minus 1. Well, that's going to be a 0 exponent, and we know that anything to the 0 power is 1, so we've got 45 times 1, or 45. So A1 is 45 over here. And r is just whatever this power is, -1/3. If you're going to type that in on a calculator, you better put parentheses, otherwise it's not going to be right. 45 divided by parentheses 1 minus -1/3. Get 33.75. Or if you want to use the fraction button, you can change that answer to a fraction. 135 over 4. Either way, both work.